Welcome to the Head Shepherd podcast. I'm your host, Mark Ferguson, CEO here at NextGen Agri International, where we help livestock managers get the best out of their stock. Before we get started, thank you to our two fantastic sponsors for continuing to sponsor this podcast. MSD Animal Health is perhaps better known as Cooper's Animal Health in Australia and for their Allflex range across the world, with a comprehensive suite of animal health and management products. Heineken is a one-stop shop for wool harvesting and animal fibre removal. The Heineken team have a deep understanding of livestock agriculture, backed by Swiss engineering and a family business dedicated to manufacturing the best. We are grateful to our sponsors for their support, helping us bring Head Shepherd to you each week. And now it's time to get on with this week's episode. Welcome back to Head Shepherd. We're doing this one live. We haven't got many online, so hopefully we've got a few questions coming in. We have had a couple of questions posted on various forums over the last little while, so we'll grab them and talk to them. But yeah, it's been an interesting year over 2024 with some pretty tough periods weather-wise, market-wise. And so, yeah, I guess there's lots of people happy to close the chapter on 2024 and look forward to 2025. It's for us as a business, it's always our best. I think we're at our best when we're helping people when they're back against the wall. There's lots of things we can select for and do that do help the cost of production in sheep enterprises. Obviously, genetics is not the quickest fix, and so a lot of the solutions people have been looking for in 2024 have been more about nutrition or management or just straight cost cutting to get through this season. But hopefully the indications are all correct and we get a much better outcome for 2025 and into 2026 in terms of prices. At least we can't control the weather, but we can sort of control how we manage it. And I guess that's probably a pretty good theme for how we approach, the businesses we work with and all of those you listening. It's what we encourage people to think about is stick to the controllables. And unfortunately, the big impact ones aren't those that we can control. We've covered a couple of questions that we've had come through, one on Twitter and one on the hub, and then we'll see if there's any that bounce up tonight. So feel free to chuck them in on the chat now or ask them live. We're happy to do that either way. But one question on the hub is from John Bell. What is the biology of dermo and the relative importance of genetic environmental factors? Is fleece rot an indicator of susceptibility to dermatitis? So yeah, good question. For those who don't know what dermo is, you probably haven't run wooled sheep, but dermatitis, or dermo as certainly called in Australia and New Zealand. So it's obviously you need the infectious agents present, so the bacteria that do spread and cause dermo. So it's an infection on the skin, so it's bacteria impacting or affecting right on the skin layer that can obviously proliferate and causes that hard crusting, which is basically a band of happy, bit of a bacteria party going on. And it's obviously you need the bacteria present, but you also need the conditions to be right. And that there's often prolonged exposures to wet conditions and humidity, moisture coming together and anyone can imagine what bacteria like to grow in. And that's what dermatitis is. You do need the infective agent, so it is quite contagious. So it's often we get it or we'll get it to spread when we yard wet sheep or whatever, and we steam them up. Sometimes we can't avoid that, things like preg scanning or whatever, when you've got to get them in for a reason. Young sheep are more prone, so getting hoggets in wet for some reason can be a problem. I guess predisposition is from sort of density of fleece, so animals that stay wet longer, which tends to be our more dense equivalent. So that's just sort of merinos and fine wool sheep tend to have more dermo. It is linked to, there's a correlation with fleece colour, so those sheep with more yellow wool will have more dermo. Those two things are correlated. Yeah, so I guess in terms of genetic, what we score is fleece rot, which is different to dermatitis, but often similar conditions result in it. And so I haven't seen any studies that separate out dermo from fleece rot and wool colour, but they tend to be similar. When you see a sheep with dermo, I don't know what comes first, chicken or the egg, whether it's dermo comes and then you get fleece rot and colour, or it's the other way around. But generally there's a fleece structure there that doesn't dry quickly and is set up to be more likely for dermatitis. So I think generally if we find dermo on any animal, they're culled. I've never actually struck a flock where there's heaps of it in there, so I'm not sure what my plan B would be if I had a 30 or 40% of them with it. And happy to hear anyone. Well, people might not want to tell me if they've had that situation, but certainly I've had the luxury, I suppose, of only just being able to knock off the ones that have it because we don't get too many with it. But a bit of management, a bit of genetics, and a bit of unluck or good luck with the weather conditions is probably the story around dermatitis. I guess we have been really focused this year and a little bit of last year maybe, but 2024 I reckon probably was the year where we really got focused on scoring wool traits. A little bit surprised, I guess, by the lack of data that is in sheep genetics for those that have scored wool colour and fleece rot. There's actually not that many records in there, which means that we've probably contributed most of them, or not us, but the scoring we've done for clients' flocks. I do think that's really important to, I guess, the more I go on through this breeding journey, the more I love scoring stuff, putting numbers on things rather than saying it's a cull, actually putting a number on it and saying it's a score 4 or a score 3 or whatever it is. And then it still might get culled because it's that score 4, but at least we know that and we can do the sire averages and ultimately we get them turned into breeding values, which is the real power. And I think probably the most, well, on a nerdish way, the most exciting thing for 2024 has been how much extra data we're being able to collect on that front and how much more power we see from that. And I know there's some breeders that have been doing that for a long, long time, and maybe not submitting it all to sheep genetics, but doing it in different ways. But I think as an industry, we're going to see a lot of power from probably scoring the stuff that we all would see and identify. But there's something really powerful about forcing yourself to put a number on it. I think there's actually been a few times this year where I've opened up a fleece and gone, oh, that's good wool. And then by the time you've scored it, it's like, it's actually a 3 for colour and there's a little band there, so it's got to be a score 2 for fleece rot. And yeah, it's score 1 character, so very nice crimp. But actually, it's not the most amazing wool because there's a couple of things there that aren't perfect. And yet, on first glance, quickly, because you weren't looking for colour and you weren't judging it against other colour, you've sort of declared it a good wool mainly through character. So character or the crimp that you see, or the definition of crimp, I reckon drives our little decision making a bit harder than some of those other traits that we can kind of overlook. Yeah. So anyway, that's a bit of a long-winded answer on dermatitis and moving in off that subject, but feel free to chuck something in the chat, or I'll open up a minute. But I'll just keep talking for a while you keep thinking. But another question was around the GEPEP project, and I should at this juncture know what GEPEP stands for. But anyway, it's a long name, which means basically trying to understand the value of whole body energy, essentially efficiency, whole body energy. So how much animals are eating, what they're doing with that feed, and that sort of holy grail of, I guess, getting away with feeding them as having them productive, but feeding them as little as possible and looking for the genetic variation around that. So the Andrew Thompson and his team at Murdoch University put sheep through a whole heap of processes. They were out of the MLP project, the Merino Lifetime Productivity Project, which was so lots of, I think, 29 different sire groups or a number about that scale anyway, that were all different industry sires that had been contributed from a range of different bloodlines. And so we're pretty representative, really, of the sheep industry. And so then the weather progeny from that. So the ewes got to stay on, and they went through to a 6-year-old, measured for everything. So a really unique project of that scale across lots of different properties or lots of different sites. A really big undertaking by AWI. But we were lucky enough, or Tomo was, to get weather progeny from a couple of those drops and run them through a whole heap of processes to work out their feed efficiency, their maintenance requirements, their whole body energy stored, and a whole heap of things that I can't remember. But yeah, basically measured for everything. And then John Young and Hutton Oddie, some of you will have heard of John Young. He's our guru economist that we rely on fairly heavily. And Hutton Oddie's probably forgotten more than most people know about animal physiology. I don't even begin to understand when Hutton starts talking. He sort of swallowed the book of ruminant physiology, or maybe wrote it, or both. But anyway, so him and Youngie have been sort of working through trying to understand the data set that came out of all the measurements that were taken to really try and answer this question around how do you shift individual traits into hectare traits? So how do you shift an individual breeding value into a per hectare profit? And to do that, we need to value all the traits. And the big one that we haven't been able to value, there's lots of things we can't value. A lot of them are the animal welfare traits, but the other big one is how much they're eating, or which animals are eating more than others. And is that a bad thing or a good thing to be eating more? And are you storing energy with what you eat, or are you just storing lean tissue, which doesn't transpose into stored energy as well? So that's been a really intriguing project. I think we wrote the original proposal definitely before I moved to New Zealand, so more than 11 years ago, more than 12 years ago. So a long time ago that was sort of proposed, or versions of it, and finally AWI were good enough to fund that, which is fantastic. It probably, I think a lot of these experiments, like all of my career, we've actually it's created more questions than answers, maybe. The more we get into it, the less we know a little bit, but at least we are solving some of the puzzle as we go. And I think, core to that has been trying to get a value on sort of fat, I suppose, and we've used fat depth breeding value as a sort of proxy to whole body energy, and sort of it started off as a kind of, we started off thinking it was a link to reproduction, then we sort of got our heads around the fact that it was actually a link to condition score, and then we got our heads around the fact that condition score is actually whole body energy, which is what we're selecting for. So we're trying to build an animal that has the ability to build energy when times are good, and then obviously use that energy when times are not so good. And we know that the Australian and New Zealand sheep industries both have times of plenty and times of not much at all, and there's been various parts of all over the place that have had long periods of not much in the last little while. And so, how do we select animals that we don't just want, I guess, fat animals that are lazy, essentially aren't productive. So it's kind of what is selecting, or what is the genetic variation in these traits. So there's what the team have found is there's big variation in how much energy, like you feed a different group of animals from two different sizes, the same amount of energy, and some will store more than others, which is mostly because some store more fat than others. So when you store lean tissue, which is your muscle, your organ, skin, all of the non-fat and non-bone bits, it's relatively cheap to lay that energy down. But the key thing is, there's two key things with that. One, you don't get as much energy back. Like, it's expensive to put fat down, as in store it, in terms of the amount of megajoules of energy it takes to do that. But every megajoule you store is pretty much given back to you. It's stored there. It costs you nothing to keep it, and the energy that you that you gain when you burn that fat is mostly back to the animal, and so it becomes a really efficient store of energy. In lean tissue, there's something called protein turnover. So when you store lean tissue, so whether it's in muscle or your organs, every day, that the protein that you had yesterday is actually new synthesized, has been burnt and then being synthesized into new proteins. So those tissues are always in turnover to keep the cells healthy and do the normal process. And fat cells aren't doing that. So fat is just sitting there like a tank of oil, essentially. Like, it's just imagine just a vat of fat just sitting around the animal, and it's not actually biologically active at all. It's just sitting there, whereas the lean tissue is burning. So, but the rate of burn is such that in about I think it's about 25 days, you've basically halved. If you had started with 1 megajoule of energy in lean tissue, in about 20 odd days, you're down to half a megajoule of lean store because of that protein turnover cost. So it's an expensive energy store to keep, whereas in your fat, the megajoule you stored 20 days later is still there, and 100 days later it's still there until you go into energy deficit and draw on it, whereas that lean tissue is just slowly eroding away. So they're the kind of, I guess the project hasn't found that, but the project has helped us to have that thought process to work out what is going on. And so we're now trying to work out what that means for different side groups and what that means for the economic value of fat or whole body energy in the selection index. And so that's the process that's going down, and making sure that we're weighting it appropriately based on that. So that doesn't mean that we would put all our selection pressure on fat or whole body energy, but it means if we get an economic weighting on it, we can weight it appropriately with other traits that we need in our animals. I guess the other thing that we've seen in that project is that as you increase fat, which is sort of linked, but as you increase fat proportion, which is done through selection, you drop the maintenance requirement because you're changing that a proportion of lean tissue. So therefore, the proportion of protein turnover, you actually end up with a lower maintenance cost. So one animal might need 8 megajoules of energy per day to maintain live weight, whereas another one might only need 7.5, just because of that different ratio. So you kind of see how you can build this animal that you can run at higher stocking rates and not have any negative impacts on that animal, and actually have a profit, or make a more profitable animal. And that's really that's the other finding from this work, is that there's no point just having genetically fat animals, so energies, lots of whole body energy, and then just run them at low stocking rates and have them running around like whales. Like, you have to actually, the economics is in running them to their optimum stocking rate, which we haven't, like, what we see from the numbers is you need higher stocking rates for those fatter animals they can maintain weight at higher stocking rates and therefore make you more money, because ultimately stocking rate is your big driver of profit per hectare. So that's that project, and I think that's probably the most that area is one of the most exciting things happening. The question on Twitter was around how does that relate to, it was from Dale Harris, and how does that relate to, I guess, non-merino breeds, composites and strongwool animals and even shedders? What's the relevance there? And I think it would be similar. Like, I don't think the work's been done in merinos, but the concepts of whole body energy and lean tissue turnover, protein turnover are all going to be the same. So I think the concepts are going to be similar. I mean, most of those breeds are starting from a higher base, so they already have probably more whole body energy stored or more fat stored than what your traditional or typical merino has. So whether the need for selection is as great as is the merino, but we haven't really proved any non-linearity yet. So that would suggest that it is just as relevant. But again, and that sort of, I guess, highlights why you can run, like, whilst crossbred sheep are heavier, you can kind of push them a bit harder generally. And so you end up with probably a higher stocking rate. I guess the other important thing here, and I'm watching the questions, there's nothing there, so I'm going to keep talking.
Yeah, I do have a question, but carry on talking about that if you want to carry on talking about it.
It'll take me a while to go for it.
At what point in your breeding program does it make sense to start breeding your own rams, and like what benchmarks should the flock be reaching before you start taking that step?
Yeah, I mean, that's an interesting can of worms. I mean, I don't think, well, there's two parts to that equation, and that one is, I guess there's two parts of the economics of that equation. One is the cost of rams, and two is the opportunity cost of slow genetic gain. And so you can't, I think if you're breeding rams because you think that you can do it cheaper than you can buy them, you might be dreaming, unless you're probably buying more than, I don't know, I won't put a number, well, I will put a number on, but I don't know if it's right. I think if you're buying more than 30 or 40 rams, you can probably justify thinking about breeding your own, but not at the expense of doing it well. And I think a lot of people kind of, if breeding rams to you means I buy one ram from my chosen stud and run it over some ewes that I've selected, and then keep the male progeny from them and sort of hand pick based on phenotype without much information, I think the cost, the loss of potential because you haven't done a very good job of genetic gain is probably greater than the money you've saved. And I think people underestimate how much time it takes to actually breed, the cost of breeding a ram. And Justin's online; he can tell us how much the cost of breeding. Also, is Mark, a couple of ram breeders here. But yeah, I mean, I think people underestimate the cost of the time, the labour, the effort to actually do it well. And we certainly don't advocate, if you're going to do it, you have to do it well. There's no kind of do it and do a half-baked effort. There is, I guess, in the world of genomics coming forward, there's probably ways you can, well, there are ways, and we help people do that, to do it in a more efficient manner. I think if you want to breed rams because you have struggled to find the rams that suit your place in the market around you, then that's a more valid reason maybe than saving money, or that you're just passionate about it and you want to get into it. I think you'd want to be hitting pretty like top 20% benchmarks, KPIs for your commercial enterprise before you sort of decided that breeding rams was your thing, or have at least ticked off the majors of sort of water wire and FERT and all those things that are kind of priorities in getting a sheep business cranking. And then you might have some time where you can breed rams. And certainly, yeah, what I would advocate is if you're going to do it, you have to do it well. And that's the same whether you're a stud breeder or a commercial farmer. I don't have a lot of time for people that want to do a half-baked job of breeding rams. I think that it's too big. The opportunity cost of doing it poorly is too big. Didn't really answer that question, but gave an opinion. Justin's asked a question. In South Australia this summer, many will be confinement feeding. What opportunities does this present in terms of whole body energy measurements of other traits that are measurable to use a negative season into a positive outcome? Yeah, good question. So I think, unfortunately, the work that was done was sort of done really accurately. So knowing how much they eat, and unfortunately in confinement, you still don't know that, but you can run them you can kind of give them a ration that means that unless they're pretty efficient, then they'll be losing weight. And so you can kind of put them on the edge of possibility, and then see which ones gain weight and see which ones lose weight. On a commercial, again, probably commercially, your job is really to have them manage them to be efficiently maintaining weight so that you can get them through without costing you too much. To let any of them drop as or too far is risky. So I think maybe the opportunities to find the strong ones in there are probably outweighed by the economics of actually looking after them. Because if you let them slip too far, then you'll know that they're poor, but you've still got half your sheep that are poor then, and you can't do much about it. So yeah, I'd wonder. It'd be interesting to do the maths, but what I would say is that it's going to be way more efficient under that confinement scenario to make sure you know whether they are maintaining weight or losing weight, because obviously to let them drop and then have to feed them up at some other point, particularly on grain, is really, really expensive. And the same thing goes with that sort of storage of fat scenario. While you've got it there, it keeps your maintenance cost down. To let it drop and then have to feed it back on is really, really inefficient. So my focus in confinement would be to get away with as cheap a ration as you could get away with, but have them, or decide whatever your condition score target is, and then plot that out and actually have them heading towards that. That might be a 2.7 to the ram rather than that ideal is 3, but in this year you might say, well, it's 2.7 or 2.5 to the ram, and I've done the maths and that's where it's going to land. But even to do that takes quite a bit of care to let them lose weight at a regulated rate, so you kind of don't miss the ball and you're down at 2.3 or 2, and then you've got a non-saleable animal that is probably going to be dry. So it's a knife edge, I guess, that game. And I don't know. I probably approach it the same way with worms. Like, lots of people want to stop drenching their adult ewe flock and then keep the ones that hack it, but I don't think the bank manager would agree with that strategy. Like, you're sort of better off buying the rams that'll do the job on the genetic front, and then maybe take the absolute tail off on the ewe front. But yeah, I think we have to be careful sort of chasing genetic outcomes or genetic selection when the actual economics are in favour of looking after them a little bit better. Again, didn't answer that question, but okay, my opinion. But I mean, if, in a stud sense, if they're in containment, it is a good opportunity to, like, in a smaller number of ewes, maybe ewe hoggets or whatever, that you can afford to feed back up if you need to or whatever. Like, that is it's a good opportunity to test out who can handle a barley straw ration with bugger all else or whatever, and which ones are going to maintain weight on that. So far, we haven't found much difference in kind of the efficiency of digestion. It's more about, it seems to be, well, there's a bit of an efficiency of digestion, but there's no efficiency in sort of cellular process. It's just whether they go into, how much proportion goes into fat and how much goes into muscle. And yeah, it'll be interesting under a confinement scenario without knowing how much they're eating. Is it like, are we selecting the ones that just have a faster pass-through rate, are able to eat more and therefore maintain, or are we selecting those that actually are putting more into fat or are already genetically fatter and able to maintain? There's a few things that we don't know when we're doing it at the level of hundreds that we do know when we've got them in an individual pen. But yeah, I think I'll probably watch this space. We'll have good economic sort of values around what the proportion of selection potential or preference should be on those sort of traits, and how to do it the best way, I guess, for different selection processes. Yeah. Anyway, I mean, the other point, which maybe was what I was going to raise before, was the current selection indexes have zero value for these traits pretty much. So having any value on them is better than none, because we know that they are economically important. And the other thing I wanted to point out was our current sort of processes of evaluating size across, like, on a central site, are a little bit flawed on this basis, because we sort of run those progeny you're going to run that group of progeny to the optimum for the group, but within there you've got some that naturally will maintain weight on less feed, and others that need more feed to maintain weight, and sort of run them to the middle. And so you've got some that are sort of at a lower stocking rate than they can handle, and therefore their profits being knocked back, or because they're not doing as much per head, but actually there could be more of them on that same amount of land, and then making more money per hectare. And then you've got other sheep that are running a bit lean, and so would actually need to be running at a lighter stocking rate to perform. And so we throw them all in the same paddock and stick them together. We measure them and we make declarations around who the most profitable sire is, or group progeny from a sire is, but it's a little bit flawed in the sense that unless they're running at their optimum stocking rate, we don't actually get to know that, and so that's what this work's trying to understand, I suppose, and because as we're making some assumptions around their maintenance requirement and their energy intake that just aren't true. So that's the kind of stuff we want to really get our teeth into, I reckon. Mark's asked, do you think there's an opportunity to identify sheep with better grazing habits, attitudes? Definitely better attitude. Penalising those animals that wait at the bottom of the next shift versus those that climb out and go looking for a feed. Is there anyone doing this? And if so, how? It's a good question. The only one I've sort of heard of is a guy in Queensland talking about like animals that will go 2 days away from water, essentially, so that you can drive into, and that comes back to the kidney setup, the loop of Henley or whatever it is. There's some of them have a better water efficiency, and that's a genetic thing. And so they can, in that country, you need to be obviously getting back to the water point is important, and why all the feed around the water points is gone, because that's animals can only get so far from that water point. I guess in high country it's a different set of circumstances, and I don't know of anyone selecting for it. There's certainly, and the only examples I've sort of heard about are ones where you've shifted sheep from one place to another and they just don't like the idea of climbing up and doing the work. But have you seen animals that, like with exactly the same breeding, some will push harder than others, like out into the hill?
Yeah, definitely. Like if you put a mob in a steep hill block, there'll be 30-40% of the mob will sit at the bottom until it's grazed to a bowling green and not go anywhere, and the rest of them are all up in, good, decent tucker.
And that's the same animals, you reckon? Or
pardon?
Like you put those animals in the next block, is that the same animals that sit to the bottom?
Well, that's what I'm saying. I was wondering. I don't know, and I don't know how repeatable it is, and whether you could sneak the bottom ones out the bottom gate and get their tag numbers, and then try and do that a few times or something, and figure out whether it's repeating.
Yeah, and I definitely think. Well, I mean, common sense would suggest that they're going to be the same. Like the ones that do drive are going to be the ones that do, and we see it in breeds. Like we see that some animals will push harder than others. So yeah, there's a good chance it is genetic, and a good chance it's got a profit equation to it, because obviously hanging around the bottom gathering worms is not that helpful. It'd be interesting to look into how we do that, because I think part of this drive, like part of what we're doing when we're selecting animals, is they're pushing up their drive to eat, essentially. Like their desire to eat goes up, and therefore we get more production out of them because they're taking more energy in. I think they would be the animals that should be out there have decided to, rather than have a nap and wait for the gate to open, they've pushed up and chased to feed. So I think, it'd be interesting I don't know of anyone doing that directly. I'm sure someone's done it somewhere, but I haven't heard of anyone doing that as a sort of selection process. But it'd be particularly interesting in high country New Zealand, where, but even in all scenarios, like there's the old sort of, I don't know, everyone that's run a few poledoucet rams with their merino ewes sees the poledoucet rams asleep under the tree half a day, wondering what they're up to. But Sophie's not happy with me bagging poledoucets, but that kind of stuff. But maybe they're fatter and efficient, and they don't actually need to go and eat to maintain weight. Like these are the kind of, like there's all these reactions and sort of combinations. We have to be careful what we wish for. Like if we select those ones that drive up to the hill, that because they've got a big appetite, is that what we want, or are the ones sitting down the bottom actually the ones that are maintaining? They're actually already got their maintenance requirement for the day, so they're just sitting around waiting for the next day to come. So I mean, these are all the good. That's why we've sort of ended up asking more questions than we've answered, because all these things just keep popping into our heads. But I do think, and even if it wasn't as efficient to drive up that hill and eat, it's still more efficient as a farmer to have something going up there and eating it, so that you're not just chewing the bottom out. And so there's all that sort of herd or flock effects that at the individual level might not be best for the animal, but as a total profitability it might be. And I think that's where we've kind of got to get our thinking onto. It's this sort of whole, like I'm not a big fan of feed efficiency as much as I am as whole herd or whole flock efficiency. Like the individual's not paying the bank manager, it's the whole. And so how do we breed them to act as to be best for the whole rather than for the individual? And that's where this whole GEPEP thing sort of initiated. And I think we'll probably, in 30 years, we'll still be talking about it, not understanding it. But but it is, I think, fascinating. And it's sort of moving us past this. I mean, I did my PhD and was really excited about the correlation between fat and repro, and it sort of got off on that bent. But I think it's got more and more exciting as we sort of try to understand what is actually happening at a biological level. And it's definitely not all about reproduction, and sometimes it's not even about reproduction. It's more about just that maintenance of cost. So yeah, intriguing times. I reckon the other thing that's probably got us excited is we had Kelsey on the other day, and I am pretty excited about this whole immunity space, and we know that condition score fat's probably going to be related to that, may or may not be, but I think there's a whole space of worm resistance, immunity, lamb survival, fatness. There's a whole heap of things that I think, as we sort of slowly wander our way towards the super sheep, these are the kind of things that we're going to be exploring. So we're going to be, while it was lovely when we could just measure live weight, fibre diameter and fleece weight, maybe it's, I think those days are gone, and we're going to be increasingly measuring lots of stuff, I think, as we seek to maximise or minimise cost, and I guess optimise that cost of production or minimise cost of production by driving up production and driving down cost. I think, it's going to be some interesting times ahead.
I once worked for a farm. They had merino, and they got rid of them into some composite because they wouldn't stop climbing to the top of the hills, and they kept dying in snowdrift. Merinos that didn't move up Death Valley. But then are they down by the gate because they've got a bit of foot rot, or it's not necessarily. We're going to split that up too.
Yeah, that's the thing. We need to understand every bit, and I think that's what we're finding with like our selection indexes these days. Like most places we go to, we've got 15, 20 traits in there, and that is a nightmare to some people. But when they're weighted appropriately in an index, you're not actually fighting it at all. It's kind of, and it's just that we want to understand more, because if you've got 5 things in there, then there's 15 other things that you've left out that might be wandering the wrong direction. And that's the beauty of scoring stuff. When you get breeding values on some of the traits that we'd be normally visually assessing, or it just makes it so much easier. And I think that's what we don't know. That's the scary stuff in genetics, rather than what we do know. And I think it's hilarious. My favourite vision, I reckon, was when you got merino wethers down low somewhere, and there's a pile of rocks in the middle of the paddock, and they're all going to stand on the pile of rocks just to get as high as they can in the paddock. Like the high country merino in New Zealand is a special critter, that's for sure. They do like to get up high, and I guess that's part of their upbringing. They love to be next to each other, and they love to be up high. Yeah. Mark's asked, is there any value or significant gain to be made from genotyping the best 10% of the young ewes every year to help make property-specific ram buying decisions? I think doing a flock profile once every 5 years or so, it does tell you where you're at as a commercial farm, and so that's doing genotyping 20 randoms out of your young ewes, and that kind of tells you what you're strong at, where you're strong, where you're weak. To do the top 10%, are you thinking as a selection tool, or as a understand where you're at benchmark?
No, probably more as a selection tool, just try and figure out what sire lines or whatever are kind of working in your system. Because I find, you go out and you buy 10 rams a year or whatever it is, and 2 years later, 3 of them have fallen to pieces. One's wool's not holding up, and you might have 3 or 4 that are still what you like, phenotypically.
Oh, so you're thinking, do a DNA pedigree of the better ones and see who dad was, kind of thing.
Yeah, I guess so. Yeah, yep.
Yeah. I can't do the maths quick enough or model it fast enough in my head, but it's something we can certainly sit down and try and spreadsheet. Yeah, and I think, understanding the sire would be, I guess, do it once would be interesting, and then work out if it's randomly across the 10 rams that were in the mob, then we're known to give up. But if there is 3 or 4 sires represented, because we'll obviously buy ram lambs or 2-tooth rams with no known, most of them don't have progeny, and we then accept that breeding value or updates to that breeding value without that progeny being entered as what it is. But obviously we know that once you progeny test them, that they do shift. I guess one counter to that is probably when now that we're genotyping more size, we're getting more accurate breeding values on those rams, and we've got more breeding values across the traits. So we've got wool colour, like some of the things that they might pack up for. Maybe we've got enough detail on the rams that we wouldn't need to do that, but it'd be an interesting exercise. I don't know if I could run the economics to convince Ken, but I reckon it'd be an interesting exercise.
I'll work on them.
Yeah. Maybe if we sell a few heap of rams, we'll be right.
Yeah. That'll be the way.
Right, we better wrap it up there. We've had some long podcasts for 2024. We don't want to make another one. I guess it's just a final massive thank you to all those listeners. Definitely the highlight of our week is when we get the listener count. Sometimes it's a highlight, sometimes it's not, depending on what the number is. But yeah, we love bumping into people this year all over the place. So we bumped into some Canadian listeners and had chats with listeners in the UK and obviously across Australia and New Zealand, caught up with lots at LambX and other places. And yeah, it certainly has been a great COVID baby. The Head Shepherd podcast will crank out. We'll be over 500,000 listens by sometime in 2025. So that's pretty cool. We've just clocked over 480,000 listens, I think, or thereabouts. So that's a lot of listening to this voice, but hopefully there's been lots of other voices to listen to that have been well worth listening to as well. Massive thanks to Sophie, who actually does all the work. I just sit here and talk to a microphone once a week, but thanks for listening and all the best for the end of 2024. May it be a safe one and a prosperous 2025. We're looking forward to continuing to change the sheep industry one step at a time for 2025. But thanks very much, and we look forward to chatting in 25. Thanks again to Heineken, who are proud world leaders in the manufacturing and supply of professional sheep shearing and clipping equipment. Thank you to MNSD Animal Health and Norflex Livestock Intelligence. They offer an extensive livestock product portfolio focused on animal health management, all backed up by exceptional service. We thank both of these companies for their ongoing support of the Head Shepherd podcast.